Okay. Today's date is the 30th of April 2026. The time now is 1:51 p.m. And I'm going to be talking about the philosophy behind the electromagnetic model. Uh, so it's basically measuring you. You. You are the interface. You are the signal. You are the signal. I did write it before from expressing this my more mathematically tonight. MMUKO is the cybernetic interface. What does you are the signal mean here? You are the signal is literally for your disability rights. Disability rights. So you have five senses you can act on. That's your forward facing senses, like your sight, your sense of smell, and slightly you can't act on, like you can't act on your ear. You have five senses you can't act on, like your sense of smell is not the same as the sense of it's not the same as it's not as powerful as dogs. Powerful as dogs sense of smell. So five times five, five to the power of four, four to the power of five is your five senses to the power of four. I don't know if it's five of four. Five to the power of four. It's six to the five senses. Five to the power of four. It's six to the five senses. We go four to the power of five. Four to the power of five. No, those are four senses. Which is 1024. What does the electromagnetic model represent in this model? So, why the electronic magnetic model, electronic magnetic model for systems? The bijection of states between electronic systems and magnetic systems respects the compass ring philosophy. That's the first principle. So you got negative, negative equals a negative. Positive negative equals a negative. Negative 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 equals a negative. Negative positive positive equals a positive. These represent operations operators operators on a electromagnetic system electronic system electronic tape as a spin charge a spin charge. So the spin charge is like the flow of electrons on a electric system, on an electric motherboard. Like the motherboard are ideally electrons flowing through a system. But when they're magnetic, they can be received and verified. When they flow through the circuit, they be transmitted, received, and verified via the circuitry board. So I'm expressing that you know this is the motherboard. First, the first person, I'll just give you the whole of you. The motherboard. Well, I'm gonna be my own motherboard by the way, because I've been a policy system presents inputs inputs a bijection of input states. Two different ways of um, two different ways to take inputs, whether electronically or magnetically. But to try to reconcile the three ways to do stuff, three ways to log in, three ways to log in. Secondary, the one was present is that the system was able to do with the right stuff. If you have a system, possibly if you're disabled, if you are disabled and you can't log in, system locks you out. System will preserve your human rights, and by preserving your human rights, system will if your hand is damaged, your hand is like shaky when you try to log in to your computer, you can still log in because it preserves the state. It has a signature of what is you. You are the signal. You are the signal. Your qualia, your physical being, is the signal the system interprets. So it's like it preserves your human because the system knows it's you. So you can always log in and get food, water, and shelter. So so if my hand, say my hand broke, my finger broke, and one finger is broken, and this is my this one used to touch. I used to touch, used to touch a fingerprint sensor. You know, why this matters? Why the electronic tape matters? There are two tapes that does computation. The electronic tape, which is the one that uses the cascades of one zeros, 1010 on a qubit, C for Charlie, U for umbrella, B for Bravo, I for Indigo, T for Tango. Compass ring, a compass ring which is north, east, south, west, and you get the magnetic basically that receives so you can receive information on the stereo system. So the goal of having two ways to compute a system, two different ways a system can compute, based on malfunction. So if one system malfunctions electronically, malfunctions, that means like say like a drone is flying and it gets lasered. That's a malfunction. It malfunctions because the process is doing it gets undefined behavior, but in the real world. So it starts to the behavior in the real world is now undefined. So unspecified. So you now get not undefined behavior, unspecified behavior. That's called a malfunction. So system doesn't malfunction. It's it preserves it switches to a retrieval state or computation. So you got to transmit, you got this is why I go to the bijection state. So you got to receive state of system. The receive state is the magnetic tape. A magnetic tape, and the magnetic tape is literally the tape that allows for you to receive. It's magnetic because computers are electromagnetic systems. So this matters to input peripherals you control because if there's no peripherals, how would you log in? If the peripherals malforms, like the keyboard, you log in with yourself, and if you're disabled, you log in with half your identity in safe mode. Think of it as safe mode when you look with half of this. So you can still perform operation based on your disability rights, which is 625 rights you need to 625 rights in the legislative articles. So I'll show you the UPAL framework and express this more mathematically via the Turing complete model. So think of a Turing tape, and you get Turing tape. You got two ways to compute on qubit rings. Let me try to find the two ways to compute. So you got a Turing machine. My battery is running low. A Turing machine is an abstract model of computation that manipulates symbols and manipulates them according to set of rules capable of simulating any algorithm. So you have the Geek for Geeks. So you have the Turing tape, the Turing machine, which is basically a Turing machine is basically you have the mathematical system here. So you have a Turing machine is fully divided as seven tuples. Q is the final set of non-empty states. Q0 is the element of initial states. F is the final set of certain states, and gamma is the final set of non-symbols of a tape symbol. B is an element of gamma, is a blank symbol, and epsilon, and basically if you malfunction, so you can detect that malfunction. And by basically, if you malfunction, basically if you lose your finger and you can't log them, that you can detect your malfunction as and switch to different login types. So it's like it's you can't just log in because your hand is torn. It's like you find a different way to log in, switch to the login mode. It's not meant to be a try to it shouldn't lock you out or lock you in to the system. And that's the beauty of the human expression. So here I'm looking at my screen. Let me show you. So you have the term machine epsilon sigma is a joint of gamma or divided by b, any blank symbol. What is symbol divided by b? Yes, this is the transition function of a partial function L R. So this is the sequence I'm trying to formulate. So you have epsilon, epsilon, such that Q and F times gamma implies Q times gamma times R to the transition function for partial function. A time machine operation is sequence. This is Boolean.com. A language is basically this is brilliant combination because a language resolvable if the Turing machine accepts when the input string of the language is either rejected or whatsoever when it's in the language. In other words, it's a language, for example, there's a string that not a language for which from the may hold. That's recognizability. May not hold. A language cyber if the assembly okay. So this is a church turn thesis. Let me try to find this. Okay. Don't worry about it, guys. But I'm expressing that the bijection of state between electrical systems. I'm not making it up. I am using the because the Turing machine is an electric tape. It returns electrical values. Basically, it means that basically it's a magnetic tape. Is it magnetic return? It's it's a magnetic tape. So it retrieves values, it retrieves answer, it returns results. And because it's a magnetic, you're gonna have the magnetic, the storage, which is basically it stores no, it stores states. Okay, think of it like this: the goal of the tape is to have. I said the electronic tape, didn't I? Yeah. So you have an initial state. Basically, you have a table, and that table returns uh, um, has information about the computational steps. But if you know the computational steps, which is the spin state, the compass spin state, you have the other one, which is the magnetic tape. So the magnetic tape is like, it's not really a magnetic tape. It's literally magnetic because it can compute can retrieve information and know the system knows itself. It knows what it's doing. It knows itself. And by knowing itself, it knows to compute, in a way that can preserve your human rights, if you have stability or not. So that's what I'm saying. The electronic tape model is very important. So if I go to my UPower framework, your rights to the power. I'll read it from there. So let me find the U-Power framework here. So this is the U-Power framework. This is what I was referring to. So this is how to basically in this is not right. This is your address space. So the 625 article mapping against UK legislation not against it. That's what AI. Your rights to the power. So your rights have powers, and that's what's mapped to the motherboard. So it's like these are states to preserve as hard addresses, as hard coded addresses. So it's all computation. So you compute, you just can't add any kind of person. If they're not preferable, so how and you don't even compute directly. And you're sorry, if you choose compute directly, how are you going to preserve your human rights? How are you going to make sure the computer doesn't lock you out? Via the profiles, not working. Because if it malfunctions, definition, if there's unspecified behavior, like something smashed, and you get malfunction, you get like the computer behaves abruptly, like it's an arbitrary state of something that's dangerous, like water, putting water, how something behaves, in kind of conditions it wasn't designed to be in. So you have the preamble. You know, it's designed especially using computer related power. So these are the specified things address space address from the sensory powers relationship. So your sensor preserve, distributed as inference. So you're gonna have A plus B to the power of A times B, which is 9 to the power 9 to the power 6 Jordans to the 5 right. If you're disabled, So I do think this computation is correct, but if your housing number is violated, so you can pick that up and sue someone via never a problem, and but it's correct. So you're gonna have domains. So you have a schema, so system can act on your behalf. You know, you know. So it's acts on your behalf, but it acts because the human rights are essential to preserve. And of this record, I've filed a lawsuit. You know, it's basically automated lawsuit. You know, so you get never a problem. That has to go to sue someone, automatically. But you have to go through a hearing date and everything. But if it can be automated, that has to go. That has to go to automated. So I'm still working with my organization, so part three. So, existence and civil rights. D1 CRAC.1. Human Rights Act 19, Article 2. Do you want, these are domain of existence, but it just, this is it's like a codec, it's like a coder and decoder. So, if it can be ordered to spreadsheet, system can take this spreadsheet and use that as the data file, and that data file will be a single codec. I mean, no, not the data file. Basically, if I can open XML file, a CSV file, or converted value with the records of this human rights claim, this kind of data sheet, a spreadsheet, then it can remedy the kind of, but it's really about data collection, data, data, data modeling. So if it finds a system, it can update kind of way you operate the system on like for example, this one saying outside the GMP existence and environmental rights. So these are all rights. These are all the rights of the domain. So you have all the rights. This is all competition enforceable. So for example, if there's a housing violation, it can operate on your behalf, and table preserve because via electronic and magnetic bijection. So if magnetic computation refers to storage, retrieve in terms of storage and retrieval, to information reader and just retrieval, you take the measurement of a system, and that system has to know it's an original space state. Let me just decay the information, let me just clarify information to the table, and that will give you a result. If it's a calculator system, you have to make a measurement of the system to take you have to by decay I mean collapse. You have to wait for it to collapse. We have to take a measurement to collapse the state. So my hypothesis stems from the idea that this is electromagnetic. So this electromagnetic, basically, it's because electromagnetic way is the speed of light. Very important. You stand the standard speed of light. Electromagnetism operates at the speed of light. There's like a flash of light. You have an EMP, electromagnetic pulse. Or electromagnetic pulse. That can destroy computers. So you have a electromagnetic burst protocol, quantum burst serial protocol, but you have a system that preserves your life, right? Because it doesn't matter how you log in. I'm not screaming arbitrarily. I'm screaming literally. I'm trying to build a login interface for this, and that login interface will address the human rights being violated in real time. So my next step is to build a system that allows me to preserve my human rights and log in by by gesture, by gesturing, log into the computer by gesturing, for MUKO OS. F for Mike, F for Mike, So if I log in by gesturing, I can, I'm gonna create just log in to show you it works. So I can log into By beating with Kimi, let me try to find how this will work. Okay, let me try to find. So here, basically, I'm trying to find make all. It's making me so. So we're gonna have NASA slash file boots. The format bin boots slash local bootloader the Assam. So this is the bootloader local bootloader Assam. What slash local local boots for bin. How about using network assembler? Yeah, okay. Dot slash boots local bootloader. Yeah, local bootloader. I'm trying to cue me image, cue me audio, cue me audio. Cue me to the system. Actually, this is before. Yeah, yeah. So nickel boot read dispute error. So this is saying it's beautiful on hard disk, but it's not okay. My battery very low now, so I have to end this video. But basically, it's a Nigerian state I'm really monitoring. This if you can, it's a Nigerian state I'm really monitoring for system. I'm trying to formulate this properly, but it does work in my model. So I'm gonna end this video now. So there's prep up all done, but the goal is this: a bijection of states, a bijection of trinary consensus states. That just means if I can wait up, I can either wait for the needle to fall or I can catch the needle. But depending on what is so, if I take a quantum measurement and if I take a classical a cubic measurement, a cubic measurement, a cubic read, I can let the quantum state decay in classical time for a result, or I can take a measurement of the system to collapse the result. And that's why the electromagnetic tape model matters. Get two tapes for bijection of states. Thank you for watching this video, guys.